For our next example, we have this circuit that has 3 resistors and a power supply. So we see that the three resistors are actually in series with each other. So we go ahead and find the total equivalent resistance by taking the 3 resistors and adding them together. That's going to be 6 plus 3 plus 12, and that gives us a total resistance of 21 ohms. All right, so again, that's in series, so we add them together. Now to find the total current, we have the total voltage given, which is 16 volts, and we have the total resistance, which is 21 ohms. So we go ahead and find our current by taking the voltage divided by the resistance. That's 16 divided by 21. We get 0.76 amps for our current. Now that we're dealing with a series circuit, any circuit that is in series, the current is going to be the same all the way around. So the current's the same all the way around. So that means the current through resistor 1, through resistor 2, and resistor 3 are all equal to the total resistance, which is 0.76 amps. All right, so we go ahead and figure out the voltage for each one. So it's going to be the current times the resistance. So 0.76 times 6 for the first resistor. That gives us 4.56 volts for the first resistor. Second resistor is going to be 0.76 times 3. That gives us 2.28 volts for the second resistor. And then the third resistor is going to be the current, which is 0.76 times its resistance, which is 12. And that gives us a total voltage of 9.12 volts. In this next example, we have 3 resistors, but you can see now that they're in parallel. They each have their own path from one side of the battery to the other. So to find the total equivalent resistance, we're going to take 1 over each resistor. So it's 1 over 8 ohms plus 1 over 4 ohms plus 1 over 12, and we get a total of 0.458. Now keep in mind, this is not the total resistance because it's 1 over the total resistance. So in order to find the total equivalent resistance, we set that over 1, and we're going to flip both sides. So that gives me the total resistance is going to be 1 over 0.458, and that gives me 2.1 ohms for my total equivalent resistance. Now that I have the total voltage of 14 volts and I have the total resistance, I can use that to find the total current. It's going to be 14 divided by 2.18, and that gives me a total current of 6.42 amps. Now for each individual resistor, I have the resistance, but what's interesting is the current is actually going to split between these 3. So none of them are going to be 6.42. They're all going to be a piece or a part of that 6.42. Now whatever current adds up, or whatever current is going through each one of these, all 3 of those currents will add up to 6.42. But to find the current for each one, the voltage is 14 volts for each one because each path has its own resistor to go from one side of the battery to the other. So each one's going to have 14 volts for its voltage. So voltage 1, voltage 2, and voltage 3 are all equal to the total, which is 14 volts. So to find the current, we take the voltage, just like we did with the total current, the voltage divided by resistance. So 14 for the voltage 1 divided by 8, that gives me a current of 1.75 amps. And then for the second one, the voltage, which is 14 divided by 4, that gives me 3.50 amps. And then the third one, we get 14 divided by 12, and that gives me a total of 1.17 amps. And if you add these 3 together, the 1.75, the 3.50, and the 1.17, that adds up to the total, which is 6.42 amps. All right, so our next example, we have a 12 volt power supply, and we got these resistors right here that are in series and parallel. So we need to figure out what the, first of all, what the total equivalent resistance is. Well, in order to figure it out, we got to kind of simplify it down. These resistors right here are in series, and that whole side is in parallel with this. Well, I can't put these in parallel yet until I combine these into one equivalent resistance. And then this whole thing is in series with this resistor right here. So once we find the equivalent resistance of this part, then that can be put in series with R4. So first and foremost, we got R2 and R3. They're in series with each other, so we just add them together. So it's going to be 5 plus 7. That gives us a total of 12 ohms. Now that 12 ohms is in parallel with this 3 ohm resistor. So that 12 ohms, those two resistors can be simplified into one resistance that's 12 ohms. So I've kind of put that in to show that the equivalent resistance, those two resistors are really, they can be simplified into one resistance. So now we have a 3 ohm resistor and a 12 ohm resistor, and those are added in parallel. Well, we do that by adding 1 over the first resistor plus 1 over resistor 2 and 3, and that gives us 1 over the total resistance. So that's 1 over 3 plus 1 over 12, and that gives us a total of 0.4164, but that's not it. We have to take the reciprocal of that in order to find the resistance, and that's going to be equal to 2.4 ohms. So the total resistance there is going to be 2.4 ohms. So now that can be replaced with one resistance that's 2.4 ohms because effectively
those two resistors make one resistance of 2.4 ohms. Now we got the rest of the circuit, and these two resistors are in series with each other, so the total resistance, and they're the last resistor, so the total resistance is going to be equal to the resistor of 1, 2, and 3 added to the resistor of 4, so that gives us a total resistance of 4.0 ohms for the entire circuit. Now we have the total resistance, which is 4.0 ohms. Now we need to find the total current. Well, the total current, if you look at V equals IR, to solve for current, we could take voltage divided by resistance. So that's 12 divided by 4, and that gives us 3.0 amps. Now, we have the total voltage, we have the total resistance, and we have the total current. Now I want to know what is the voltage and what is the current through each one of these individual resistors. Well, this part right here, it's the resistor 1, 2, and 3, they're in parallel with each other, but that's the current actually splits there, and we know that the voltage is going to be the same on both sides. However, we don't know how much because R4 is using some of the voltage. But we do know that all the current has to go through R4. Even though the current splits up here, it comes back together, and all of that 3 amps has to come through R4. We don't know how much goes to each side, but we do know that all of it has to go through R4. So if we know the resistance and we know the current for the fourth resistor, we can multiply them together in order to get the voltage. So it's 3 times 1.6, which gives us 4.8 volts. Now we know the voltage and the current for resistor 4. Now how can we use this 4.8 volts? Well, if the total voltage is 12 volts and this uses 4.8, that leaves a remainder of 7.2 volts. Well, 7.2 volts have to be used in this part of the circuit. 7.2 volts is left over. Now, if you notice on this side of the path, with parallel, the voltage is the same on both sides. This side of the path only has one resistor, so the 7.2 volts has to be used by this resistor over here, but 7.2 volts also has to be used over here, but that's going to be split between R2 and R3. So in order to determine the current through R1, we have the voltage. We go ahead and take the voltage and divide it by the resistance, and that gives us 7.2 divided by 3, which is a total of 2.4 amps. So now we have the voltage and the current used by resistor 1. So the next part is we need to figure out what is the voltage used by resistor 2 and resistor 3. Well, the total is going to be 7.2, but we need to figure that out by using the current. Well, the current through this part we don't know, but we do know the current over here is 2.4 amps, and we know that the total current is 3.0 amps. So the remainder of the current, the 3 amps minus the 2.4, gives us 0.6 amps. So that means that 0.6 amps have to come through R2 and R3. So we know that the current for 2 and 3 are both going to be 0.6 amps. Now we can use the current and the resistance in order to determine the voltage for each one of these. So the voltage is going to be equal to current 2 times resistance 2. So that's going to be 0.6 times 5, which gives us a total of 3 volts. And then for resistor 3, we use the current and resistance. We get 0.6 times 7. That gives us a total of 4.2 volts. And you can see the 3 volts here and the 4.2 volts here add up to be 7.2 volts, which is how many volts need to be used on this side of the circuit. Okay, so we got the total voltage, the total resistance, and the total current. We got the voltage and current through each one of the resistors. So the next thing to do is to figure out the power. To figure out the total power of the battery, we take the current and we multiply by the voltage. So it's going to be 3 times 12, which gives us 36.0 watts. For this first resistor, the power is going to be 2.4 times 7.2, and that gives us 17.28 watts. For the second resistor, 0.6 times 3, that gives us 1.80 watts. For the third resistor, we get 0.6 times 4.2, that gives us 2.52 watts. And then for the fourth resistor, we get 3.0 times 4.8, which gives us 14.4 watts. Now, something interesting here is you may notice that the power here, these 4 powers, add up to be the total power of the circuit. So those add up to 17.28, the 1.80, the 2.52, and the 14.40. That equals 36.0 watts, which is equal to the total power. So the total power used by each one of the resistors is equal to the total power given by the battery.